Hi coders, welcome to Coding Every Day. My name is Otto and this is yet another episode of the Asta Manager project. In the last episode we implemented the domain logic of our application, and in this episode we'll start adding some infrastructure. In our case it's going to be an in-memory implementation of the repositories so we can store some data in memory, and we will use this in the future for testing purposes. Uh, then in the next episode we will have a look at how we can do the same but with an actual Cosmos DB implementation. So let's get started. Before we start adding the in-memory repositories, I want to show you what I missed to show you last time. Uh, I just realized that when I was about to commit the current branch, I was missing Git Ignore files in these new projects that we created. So I essentially just copied it from the Azure Functions one and I duplicated it there and there. Another Git Ignore file that I've added in the root folder of the repository of the Git repository. I added a simple one here just to ignore the VS folder that is created when you open the solutions. Um, you might not have that, so depends if you use Visual Studio or Visual Studio Code for your backend. In my case, since I'm using Visual Studio 2019, it will create a .vs folder that I want to ignore. For the other projects, of course, when you build, you're going to have the build and the bin and obj folders. So I added the git ignore there just to make sure that we ignore the files that we don't need. And the only things that we have in source control are the actually files that we want as source control, and the generated files are not included. Okay, now let's move on and let's create an implementation for some of these repositories that we have here. So first of all, we need to create a new project. It's going to be, as usual, .NET 5. We will start with the class library, and it's going to be Asta data in memory. In the next episode we will have Cosmos DB implementation as well. So as before, we don't actually need this class. Look at that, it even deleted the reference in the project, which is good. Now the first thing I want to do is create the repos folder, and in this repos folder the first thing that we need to do, we need an actual database representation in memory. So let's create a new class in here. So in memory database we'll call it, and it's going to be a public class obviously, and in this class the first thing that we need a place where to store the data as if it was an actual database. So what I came up with, but you can come up with whatever you want as long as it works, I came up with this containers dictionary. So it's a dictionary that, given a container name, it also has another dictionary, and this other dictionary is a list of partitions where the string, the key is the partition key, and obviously every partition will have a list of documents where we have the key, which is the ID of the document, and the data will be serialized as JSON in our case. The reason I decided to serialize it as JSON is just I want to make sure that when you read from the database, you create a new class in memory, so that even if you make changes to it, it's not going to apply in memory database straight away. So it's always a copy when you read, or write is always a copy, and if you make further changes to the classes that you use it to read or used to insert or update, is not going to affect what is actually stored. This might be a little bit less efficient, and it might be a little bit resource consuming for the, I think, both processor and memory, but we can live with it because we are going to use this only for testing purposes. So for a small test, I think this will work fine. So let's go ahead and see what methods we need. We need the usual methods, right? We need the CRUD operations, and we also need something that we can later use with an implementation of this I repository. So we need a way to find in a specific partition all files based on a condition. Okay, so let's go with the first method, which is the read document. So this is a generic method that gives you a container, a partition, and an ID. It will read. First of all, we need a method to get or create a partition, just to make sure that we have everything we need. So this is going to be a private method. I'm not going to type it in just because I don't want you guys to be annoyed by me typing. And of course, when we get or create a partition, we need to do the same for the container first. So we also have a method to get or create a container. So these methods are quite simple. So we have a container object temporarily stored here in this C variable, and if the container exists, then C is that container. If it doesn't, we create a new one and we add it to the list, to the containers dictionary, and we return C, which is the container that we are working on. Pretty much the same thing applies for partition. We read from the partition. If we check if the partition is there. If the partition is there, that's our partition. If not, we create one, and the created one is going to be our partition. So that's how we have our partition here. And of course, in the partition, if the document exists, in the case of a read, then we just deserialize it. And the only reason I use this task run just to make sure that this deserialization works in another thread. Let's add this deserialization method. We will add a serialization as well. So this is just quite simple and straightforward. You don't have to do it this way. You can come up with your way to do it, probably better than I'm doing here. So deserialization is essentially just using the standard JSON serializer to deserialize the JSON, and serialization again using the JSON serializer to serialize the document as string. And if we go back to our read, yeah, now this works. The only thing that we also need is we need an exception class just to identify that these exceptions are coming from our database class in memory, just in case we have some issues. So we are trying to read something that doesn't exist. Of course, the Cosmos DB version, so Cosmos DB will fail if we try to read a document that doesn't exist, and our in-memory database will need to do the same. Otherwise, what we test as in memory, it's not going to apply to what we then encounter as an integration test, or what we encounter when we actually use the Cosmos DB implementation in the future. So let's add this exceptions class here. this is a public class and it has to implement this, and I will just generate all of them, and I think it's good enough. We don't need anything else other than the message. Now if we go to our now it all builds. Of course we are missing some other methods here, so let's go back and add all of those. So we have the read, we need an update. Sorry, I had an issue there. So we do need Asta document, but in order to have that we have to have a dependency on the domain core, but is the domain core, so that's not a problem to add. So once we add that, of course we can access the partition key, the ID, etc. Let's add other methods. We need also a delete method. So the update is quite simple and self-explanatory, really. So we check if the document exists. If the document exists, we serialize to it again. If the document doesn't exist, we throw an exception. And at the end, we read just to make sure that what we serialized we can deserialize, and the deserialized version is what we would get. And that's it. For the delete, this is quite simple. We get the partition, we read the document. If the read doesn't error, then we just remove it. And finally, for the find functionality, we can have this find one function in our in-memory database, where we get the partition, then in our case we deserialize everything and in that partition, and then we run the condition on it. I know it's not efficient at all, depending on the number of documents that we have in there, but again, for testing purposes and at least for now, this is fine. And we can also improve it in the future if we need to, if we are planning to do anything more, or if we see that this is a bottleneck. Okay, I think these are all the methods that we need for the in-memory database. So now we can go ahead and create an in-memory repo. So let's create another class for that. In-memory-repo, and this is also a public class, and is generic, and it obviously implements our repo that comes from the core domain, from the domain repos, and the data. Okay, so we implement the interface and generate overrides. No, we don't need to generate overrides. But why is it complaining? Okay, so it's complaining, sorry. It's complaining because data needs to be of type Asta document that comes from models. Okay, so let's see how I implement all this. So first of all, we need a constructor, and in the constructor, of course, we have our database, we have our container, doc type, ID generator, and everything we need. So let's add fields for all of these, and also add null check for all of these. We don't need null check for the ID generators, because If it's null, we are going to use the default one. So let's create the default ones. So these they are. Actually, I think I'm going to put them there. I know you're supposed to have the constructor as the first thing in the class, but it just feels weird to me that in the constructor we use fields and stuff. So I prefer to have fields first because they don't depend on anything, and then properties, and then the constructor. Just feels better to me. So the first method, let's move it up. The first method we are going to implement is the insert. So for the insert, we just use the database to create the document, and of course this needs to be we missed the create, update, delete, find one. Yes, we missed it. Okay, so the create method is this one. Let's put it here. So again, we get the partition. If the document exists already, then we throw an exception. Otherwise, we serialize and store it in the partition, which in our case is just a dictionary, and then we read the document and return what we read from the database in memory. Okay, so now we can read, but before we read, I would also like to add something to it, which updates all the fields. I mean, it's going to use the ID generator and the partition generator and the doc type that we specified in the constructor to make sure that those properties are updated. So let's create a private method here that is going to do just that. Just grab the doc type, and of course if we have a partition key, so if the partition key is null or empty, then we take the generator. If we don't have a generator, we use the default one and invoke it. Otherwise, if we already have a partition key for this object, we will just keep whatever we have in there. Same for ID. So yeah, the insert is like that. We update the fields just to make sure that they are updated. In case you want to insert a new object, you just need to create the object and initialize the fields that you actually need with actual data, and then you can forget about creating an ID for it and a partition key. If you have proper generators in the constructor here, they will be generated for you. Let's continue. Let's add a read method. So the read method is actually even simpler than the insert one because we don't need to update the fields. We are just going to use the ID and the partition that comes there and read the document from the database. Then we also have the update, just going in order because create, read, update, and insert. So crude. Update is similar to the insert, just instead of inserting or creating a document, we update the document. And then the delete is also quite simple. We just call the method in the database, in memory database. Call it database, but it's just really a bunch of dictionaries. So for the find one or null, what we can do something like this. So we can find one. This needs to be a string, and we can find one for this container partition and this condition, and the database, for how we implemented it at the moment, it will throw an exception if that happens, and in this case we will just return null to note that we used our exception class that we created, just so if anything else errors, then we don't catch it and we see the actual error. Let's say that we are trying to do something weird and it's not going to be this kind of exception. Maybe we have an error in the implementation or things like that. The next thing I want to add is a repository factory, so that in dependency injection configuration we only have one line of code to specify new repository, and in order to do that, let's go to the domain core and add a new interface. Interface factory, and this repository will only have one method, and we need the using statement. So given a bunch of parameters to create the repository, it will create an instance for us based on the configuration in the dependency injection. So in this case we will have an in-memory version of this repo factory, and we will have a Cosmos DB version of it, and it has to be public. Okay, let's create a class here to implement that. And it's going to be public factory. And this comes from the using statement, and we can implement it, of course, because this is the memory version. The first thing we need in memory database. This is going to be our database, and we create a local field and we add a null check for it, and of course here we have a return new in memory database, so in memory repo data database container type the generator and partition generator, and that's our factory. The next thing I want to add is a little helper method to allow us to easily add all the things that we need for an in-memory version of the repositories to the dependency injection. So it's just a helper method, and we will add that as an extension method on the services collection. So let's create a new class. Not in there. I will move it out. I wanted it in the root. Yeah, so it's going to be there instead. So it's a public static class because it's going to have extension method in there, and the extension method is this one. Of course, because we don't have the packages installed, but let's see if Visual Studio helps us. Yes, it does. So what we need actually we don't even need that. The package that we need is give me a second, is just the abstraction one. So let's go and add the package manually. So there are two packages, is this one with abstractions, and there is one that is without abstraction, that comes with a lot more things in it. We need the abstractions one because we only use the interfaces of the I collection in this project. So looks like we already have one. So in case you don't have it, you just need to add it. I think this is just because my recording software stopped and I had to revert some changes and I forgot to revert this one. So just add that, and then you should have the using statement at your available. And we need the using statement for the repos and the using statement for this. And that's pretty much it. So when we use this method, we know that we already have these two and we don't have to remember those two all the time. Let's see if this builds, and it does. Okay, so the next thing that we need is to add some tests to this, just to make sure that what we implemented so far actually works. So let's add a new project, a class library. We start with that, and .NET 5, and it's fine. So we need a few packages here in order for this to be a test library. So we delete the class that is generated there, and we go to add some NuGet packages. We add this, and this will mark our it will come with a bunch of things that we are missing at the moment, and we'll mark our project as a test project. Obviously you read every single license instances here, and then you accept. And as you can see, as soon as we installed that, the icon of the project changed to the test icon, to the test class library icon. Okay, we also need other other packages. It really depends on what test framework are you using. In our case, we will use MS Test, so we go ahead and install the MS Test adapter. Just follow the instructions for whatever framework you're using, what packages you need for your case. So let's install that. We will also need this other one here, the framework. So I accept all those, and I want to install that as well. And okay, and I accept. Now that we have the dependencies that we need, we can create a repo folder. So it's repos, and let's add a class that is repo tests. This has to be a public class, and also has to have the test class method to identify that this class is an actual testing class. Okay, let's use a dependency injection in our tests as well, just so that we mimic exactly what would happen in production. The only difference is that instead of using Cosmos DB repositories, we use the in-memory version that we just created. So first thing first, we need a collection to store our services in, and we can install don't need that package. Give me a second. So we also have a constructor, and in the constructor we can actually initialize that services method with a proper collection. So in order, we need this package. So it's Microsoft Extensions Dependency Injection without the abstraction bit, because we need the actual implementation of it. And it will come with the interface as well, so this depends on the abstraction anyway. So let's add the missing using statements. In order to do that, we need to add a reference to our core project, and we can find that helper here, and add all the other usings. And we also need to add a dependency on the in-memory project there, and now this will go away, which is fine. So now every time we request an iRepository of account data from this service collection, it will actually try to get the registered iRepo factory, and that implementation, which in our case, because we are using this helper method, is going to be the MemoryRepo factory. It will create an in-memory repo instance, and we'll use that in our test. Okay, the next thing we need is I created here a property that every time you call it, it will generate a new account data object for testing purposes, and then we can start actually implementing the tests. So first thing, we have insert tests. I will just copy this in and try to explain. So the first test we do is try to generate and check that when we insert, we actually generate a new ID, and we generate the default partition. So we create our service provider, we create a new account data, we make sure that ID and partition key are both null, and then we request from dependency injection a new instance of this iRepo of account data. We do the insert, and we check that ID is not null in the inserted version. We can also check that the ID is the same length of a GUID, because we know that's our default implementation. So if we go to our in-memory repository, you will see that this is just a new GUID serialized without the dashes and to lower, which means that in our test we can test the length and make sure that that's the same. We can also check the partition key is not null, and in our case that the partition key is default. We can also check that the doc type is being populated correctly, and I think it's also important that we check the actual data of the object that we are saving. So in our case, the display name and the user in there. Another test that we have is that we keep the ID and partition if we provide one. So if we don't set them to null, then we expect the partition key to be partition test instead of default, and of course the ID is going to be the empty GUID instead of being, sorry my stomach, I'm hungry. So then we also need to test, of course, the setpath, not just the happy path when it works. We need to make sure that if we try to insert it once and then insert it again, it will throw an exception. And also another test that we can do is that if we insert in two different partitions, it will work. So now that we added some tests, we can build our projects just to make sure that everything still builds, and then we will run the tests. So far so good. Let's copy in the other test that I prepared earlier, and we'll just go to them in a second. So we've seen the insert one, we have the read ones. So of course we have the setpath when we try to read something that is not in the database, and we expect to receive this kind of exception. But if we do insert it, then we also check that the data that is inserted is what we expect, and of course there's no assert that anything errors. For the update, again, we try to update something that doesn't exist, it will error. If we try to update something that is already there, we change some data, we update it, and we check that the data is the updated version. For the delete, similar, it will fail if we try to delete something that doesn't exist in the database, and of course it will succeed if we insert first and then we try to delete. And we can also check that the data that is returned is the actual data that was deleted. For the find one, we can test that if we insert something in the database but the condition is something that always returns false, it will return null because no document will satisfy that condition. And we can test also the happy path when we try to get the document by display name, and we check that the data is the data that we expect. And that's it, we have our testing. Let's build the solution again, and then we'll try to run all these tests again. So let's run all of these, and we have all the tests passing, which is great. Now, before we commit, another thing that we need is to make sure that we have all these we have this Git Ignore for these other projects, so that we are not going to do the same mistake again. And if we go to the Git changes, we should only see the changes that well, in my case I will see something different just because I'm in the wrong branch, but yeah, you need the Git Ignore files to make sure that the bin and obj folders are not in source control. I think that's it for this episode. In the next episode we will see how to do a similar implementation, but with Cosmos DB in this time. And thank you guys so much for staying with me. I hope you had fun and you learned something. Make sure you subscribe so you don't miss the next episodes, and put a thumbs up if you like this episode. Thank you guys. Bye.